Good morning, eighth graders. So this is 3.3.0 notes planetary data. Um, this is going to be broken up into two separate videos, but I will put them back to back in my playlist. Um, for the pure fact of it takes longer than just one video to really get through all the information I want to make sure that you get. This one will probably be a little bit shorter as compared to the next one, only because there's more facts, yes, but we really only have three planets to go through, not four plus potential research and all that kind of fun jazz. So this is planetary data where we're going to focus in on the inner planets, but we will get to the outer planets next. So we are really focusing in on Middle School Earth Science Standard 1-2, which states that you'll be able to use a model to describe the role of gravity in the making of our or gravity in the what? Holy Hannah. In a model to in the motion within gravity, galaxies, and the solar system. When I record, my face appears here. So it just blocked it out for a second, and my brain is not braining right now. So basically, what you should be able to do by the end of this whole thing is analyze and interpret data to determine the scale of objects within our solar system. The actual scale of our solar system is redonkulous. Um, Develop and use a model to describe the role of gravity in the formation of our solar system. So it's just kind of like verifying things that we learned just the other day. And then support your claim with evidence and reasoning to demonstrate that gravitational interactions are attractive and depend on the mass of an object as well as its distance. So we're focusing in on the four closest planets today. And then next will be the four outer planets. This is a longer set of notes, but only because there's a lot to kind of go through. And then you have this separate sheet, the very first one listed, which is something that you're going to really, really, really want to make sure you have filled out accurately, because we will come back to it for your assessment. So, the properties of our inner planets. So these are the first four: Mercury, Venus, Earth, and Mars. And as we discussed in the structures of our solar system, these are very, very small, but very, very dense planets. They are made up of heavy metals and rocks and things like that. So we also consider these four planets terrestrial planets because they have actual terrain. There is a surface that, barring how long it takes to get to these planets and the intense heat of the sun or their atmosphere, we would actually be able to stand on all of them. So that they're mainly made of rocky and metal material. And like I said, you'd be able to stand on them if you were able to actually get to their surfaces. So we are talking the first four. We're not going to talk about Earth a whole heck of a lot because we literally spend the whole year talking about Earth. But we're going to focus in on the other three inner planets as well as some of their moons and special little factors that make them so unique. Just like how each person is different and unique, each planet is different and unique. So let's start closest to the sun, Mercury. This is our smallest planet. It's itty bitty compared to the rest of us. So it only has a mass of 3.302 times 10 to the 23rd kilogram. So remember when we see scientific notation, 10 to the whatever power is like saying you're going to move the decimal that is there those amount of times. So if you were to take that decimal right after the first, in between the threes, you would move it out 23 times. And wherever there is currently not a number, just put a zero. So it's massive still. All of our planets are massive. But this is the smallest out of all of them. Its diameter, so all the way around it, is only 4,880 kilometers. Um, that is roughly 3,032 miles, um, which would be like traveling from Fargo, North Dakota, down to Panama in Central America. Which, when you put it like that, you're like, oh wow, that's really not that far because you could fly that in a couple hours. Um, and all of this. So it's not big at all. It is only a little over a third of the way between the sun and us. So, average distance from the sun, we're going to measure it in what we call astronomical units or AUs. And essentially, one AU is just the distance between us and the sun. These would be like the little mile markers in between. So that. Now, here's where things get just a little different. Mercury's period of rotation, so its day, spinning on its own axis, um, is 59 Earth days, or roughly 1,416 hours. That's their day. It has one of the slower rotations, um, but it's really, really close to the sun. So we have to remember that the closer to the sun we are, the harder it is for things to turn on their own axis. Its period of revolution, so its year, is only 88 Earth days. So you barely get through 2 days on Mercury before Happy New Year. So that sort of a thing. Which, if we were to break that down into years, that is only like 0.24 of our years. Um, so yeah, so it's only like 24% of our year, which is a little less than a quarter. So we're talking like 3 months. That's it. Here on Earth. Mercury doesn't have any moons. It's just far too close to the sun to be able to sustain its own natural satellite. And then the gravity ratio, so how heavy we would feel on Mercury versus how heavy we feel here on Earth, is only 0.38. So we weigh just a little over a third of our mass. So if you are a 100-pound human here on Earth under our gravitational pull, you're only like 33 odd pounds on Mercury. Um, the one thing you notice when we talk about um, brain fart, holy goodness. When we talk about the different planets, is that their names are very unique in the fact of they all have some sort of Roman or Greek like surname. They came from gods and goddesses or characters within the Roman or Greek mythology. So Mercury is no different itself. Mercury is named after the Roman god of swiftness. So the Roman god that is considered really, really fast. And that's because it has a very short year. It moves around the sun very, very quickly compared to everything else that is about to come. So makes sense as far as that goes. So let's talk about Hermes. So Hermes is the Roman messenger god. And this is just the other name that it has been given because of its fast moving around the sun. Um, Actually, I think Hermes is the Greek god, but hey, who am I right now to argue with the notes that I apparently did? So instead of an atmosphere on Mercury, um, it has a very thin exosphere, composed primarily of oxygen, sodium, hydrogen, helium, and potassium. The issue with this exosphere is that when it is facing the sun, it essentially gets burned away because it is just so stinking hot. So the surface temperatures can be wildly dramatic and different. So the side that is facing the sun can reach surface temperatures of like 450 degrees Celsius or 800 odd degrees Fahrenheit. To where um, that exosphere just isn't able to maintain itself. But rather on the back side of Mercury, so the side that is not facing the sun, it cools down to generally minus 170 degrees Celsius or minus 274 degrees Fahrenheit. So you go from one extreme of complete baking and boiling to frozen solid. So that there is a lot of colors, as you can kind of see. A this is a photo taken in multiple different light spectrums, um, to where Mercury is actually very, very colorful. It has this colorous basin, which is just essentially a like a bowl that has been chipped away thanks to different asteroids and whatnot that have come and hit the surface of Mercury, as well as the different atoms that are being blasted off from the sun during any sort of solar flare or just like spark sort of a thing. So it leaves this very colorful sort of image left on Mercury. The basin itself, or this like big bowl almost with it like on Mercury, is roughly 1,500 kilometers wide, or about 963 miles wide, which isn't very far, but it's a lot when you talk about how small it is. I want to say, like, if you were to travel about 900 miles from Fargo, it's probably like Colorado-ish. Um, I don't know. Let's quick. Ooh. Oh my goodness, how many different things do I already have open on my phone this morning? So if we were to go from here to Denver, how many miles? Yeah, 857 miles. So if we were to go from West Fargo, or Horace, technically, where I'm at this morning, to Denver, that's about like 3/4 of the way, if not a little bit more, through this basin on Mercury. So kind of a big deal. It's a really interesting planet. We don't know a whole heck of a lot about it because we know that it's not something that we would be able to inhabit one day because of these varying surface temperatures. But it's still a big deal. Mercury, you're able to actually see in our night sky just before the sun were to rise in the sky. So yeah, I mean, not every day, but that's really kind of cool. So yeah, so take a peek outside, see if you see this bright colored, this bright star in our morning sky. So that is it as far as our whole group. Just to kind of give you a taste of what are we going to be learning about over the course of probably 2 class days, if not a little bit longer, because it's a lot of information. But yeah, make sure that when you're working in class, you are being respectful of your champ's expectations. And yeah, so let's get going. Venus. Venus is so fun and interesting. It is the second planet from the sun, and it is the most similar in size in comparison to the Earth. Um, it is about 81.5% of the Earth's mass, which is the closest to it. Its diameter is the closest as well. So let's talk about this a little bit in context. So the mass of Venus is about 4.867 times 10 to the 24th kilograms, which, like I said, is about 81.5% of Earth's mass. Its diameter is 12,104 kilometers wide. So from one point in the equator all the way around to back to that point, which is very similar to Earth's, being that Earth is 12,756. So only 600 more kilometers wider we are compared to Venus. So kind of cool. Now, here's where Venus gets really interesting. Its period of rotation. So the time it takes, and I have to I'm so used to going this way. Venus actually is in retrograde. It has it is the only planet in our solar system to rotate clockwise. And because of that clockwise rotation and where it is within our solar system, its day is roughly 5,880 hours here on Earth, which is about 243 days. So Venus's one day, which is actually longer than its year, Venus's one day is almost equivalent to our year. Just crazy. So that it's about a little over half. So we're looking at yeah, we're looking at probably 8-ish months of the year, is how long this would take. So, weird. Its period of revolution falls right where it should as far as how far away from the sun it is compared to us, where it takes 225 days for it to go all the way around. So it does not complete one full day within one full year. Venus is weird. So its period of revolution is 0.62, which is about 2/3 of our year. So we would be looking at 8 months. 8 months. So 8 months is its year for us. Again, it is just a tish too close to maintain its own natural satellite. So it doesn't have any moons. And then the gravity rotation, because it is so similar in size to us, it is about 0.91 compared to our 1. So if you weigh 100 pounds here on Earth, you weigh about 91 pounds on Venus. So, weird little factoids. Earth's twin, Venus. These are two pictures of Venus. How it has appeared to us over the many, many years we've been studying it is on the right. How it actually appears when you kind of take away all that graininess and get a good picture is what is on the left. So Venus was first observed by Galileo Galilei back in 1610. So we were made aware of Venus's actual existence back then. Venus is named after it's the only lady name throughout our entire solar system, which is crazy to think for me. But I mean, out of the 8 main planets, it's the only female named planet after the Roman goddess of beauty and love. So that Venus is like Aphrodite in Greek mythology. It has an intense greenhouse effect because its atmosphere is so thick, especially for an inner planet. So because of what all of the atmosphere is made out of, it holds in that temperature from the direct rays from the sun at such a significant rate. The surface of Venus can reach anywhere between 450 and 475 degrees Celsius, which is about 842 to 887 degrees Fahrenheit. Your oven cannot even get that hot. I think some industrial sorts of ovens can, but commercial home grade ovens cannot. Um, the surface is covered by solidified lava, which scientists believe were active about a half a billion years ago. Um, so 500 million years ago. We think that it was a very actively, like, a active tectonic platey sort of um, planet that has at least had some time for that material to cool. Um, so to actually cool to where you get that solidified like surface. Venus is in retrograde. So we talk a lot about retrograde when you have more of those like crunchy sort of friends. Um, where it's like, oh my God, the planets are in retrograde. That's why everybody is like freaking out. So it has a retrograde rotation. And what that means is that it's actually moving in the opposite direction than most planets. Every other planet, except for one other, which we'll talk about later, um, so Venus and one other planet are the only ones that are not rotating counterclockwise. They are well, this one, Venus, is rotating clockwise, which is just very, very odd. But you always got to have that one little oddball. So that because of the solidified lava, the actual terrain of Venus is very mountainous. So you have a lot of mountains and then valleys, and there are tens of thousands of volcanoes on this planet. And this is what caused all of that volcanic eruption to then solidify into the surface we kind of know today. It has mountains that are taller than Mount Everest here on Earth, which is our tallest peak. So yeah, Venus doesn't have any moons or ring systems or anything of that sort because its magnetosphere is just so weak because of how absolutely slow it is rotating. Um, so with how quickly we rotate, we're able to create this invisible shield called a magnetosphere that is that's having the same effects as gravity on its attraction to other objects. So in particular, this is how we maintain our moon. Um, so yeah, so it rotates so slowly that it cannot maintain its own magnetosphere, which is huge. So no moons, no rings. It just moves really, really slow. Really odd that it actually has stayed where it needed to for so long. So the Earth. So we're not gonna like this is the only slide I have on Earth because I want you to still have all the data, but we live here. We're going to learn about it throughout the rest of the year. So we're not going to spend a whole lot of time on this. So the Earth, it is the third planet from the sun, and we amazing humans live here. It is the only place in the known galaxy to have water that exists in three different states of matter: solid, liquid, and gas. Um, which is huge. We are aware of other planets and moons that have water in frozen sorts of states of matter, but oh my gosh, but not in a liquid or gas state. We have the perfect atmosphere to protect the surface from meteors, from the sun's radiation, from a lot of galactic radiation, and things like that. It is within what scientists call the habitable zone, but how a lot of people like to refer to it as is it is within the Goldilocks zone, where it's not too hot, it's not too cold, it is just right in order for us to maintain life. So that the mass of Earth, 5.972 times 10 to the 24th kilograms. It's heavy. Yeah, that. Its diameter, like I said earlier, it's about 12,742 kilometers wide. It takes a while if you were to travel on the equator to go all the way around it. Um, its average distance from the sun is 1 AU. This is where we came up with that standard, is just where we are. We are 1 astronomical unit away from our star. Our period of rotation, so how long it takes us to spin on our own axis, is 24 hours. Our period of revolution, so in order to go from one spot in the solar system all the way around the sun and back to that same spot, is 365.25 days. This is where we earn our leap year. So it's 1 year long. We have one moon. That's what we call it. Because we have a magnetosphere that is working the way Venus's should. But it's able to keep the moon where it is in our revolution and rotation. And our gravity ratio is 1 to 1. So if you're 100 pounds, you're 100 pounds. And that is of weight. So there's the Earth for you, quick in a little nutshell. And like I said, we're going to literally spend the rest of the year studying the Earth. So let's not waste our time. Let's keep moving through our solar system. Mars. Mars is our fourth and final planet that we're going to discuss in this video. It is fourth from the sun. We know it as the red planet lovingly. And that is because it is rich in iron oxides that are present on the surface, which gives it that red color. So Mars, kind of a weird little phenomenon as well. So its mass is actually really small compared to Earth. It is 6.39 times 10 to the 23rd kilograms, which is only about 10.7% of Earth's mass. Its diameter is nearly halved at 6,780 kilometers around. And the average distance from the sun is 1.5 times. So it is another 0.5 AU away from us. So kind of weird. With its distance from the sun, so it takes about 8 minutes for the light from the sun to meet us here on Earth. The way that a lot of people like to remember that is more so like it would take 8 minutes before we knew that the sun had gone out, because it takes that long for the light to travel from the sun to us due to our distance. So it takes us 8 minutes. It takes Mars 13 minutes for light to travel. So yeah, its period of rotation, so how fast it's moving on its own axis, is very similar to ours. It only takes 24.6 hours. So that. Before we get into revolution, we need to know a little factoid. On Mars, we call a day a sol. So it takes 669.6 sols or days to complete a revolution around the sun, which here on Earth would equate to about 1.88 years, meaning that it takes about a year and 9 months. 9 months? No, because that'd be 6. Call it 11 months. I don't know. I'm not the math teacher. So it takes nearly 2 years for it to go completely around the sun, and the time it takes us 1 year. Mars has 2 moons. Not for very long, but it has 2 moons. We'll talk about that here in a moment. And the gravitational ratio is 0.38. So if you were 100 pounds here on Earth, you're only about 38 pounds or 40 pounds on Mars. So, big difference. And that is just due to its mass and diameter. It is so much smaller, almost half the size of Earth. Our red planet. So, Mars was first discovered in 1610-ish, again along with Venus, when Galileo Galilei was observing um, planets. This was the first planet to be observed through a telescope, which is kind of a big deal. It is named after the god of war due to its red appearance and the fact that red was highly associated with masculinity, youth, and just the male gender during these times. So that's where it got Mars. Um, if we thought we were cold, like here in North Dakota, Mars takes the cake. So average temperatures on Mars are about negative 80 degrees Fahrenheit during the winter, like just on average. Um, which can also like, and that's Fahrenheit. But winter at the poles can get to about minus 195 degrees Fahrenheit. Um, Hugely cold. As you can see in the top picture, Mars does have polar ice caps, which is amazing to see. And this is why, for so long, scientists thought that Mars was going to be our answer for, excuse me, our answer for a potential planet to inhabit. Because it's like you have polar ice caps, you have water, kind of a big deal. Unfortunately, the liquid water has dried up and it's just the polar ice caps, and I don't know what their like purification is. So, kind of a big deal. Um, on Mars, there is Mount Olympus Mons, which is the tallest mountain in the solar system. And I say mountain slash volcano because it once was an active volcano. It is about 13 miles tall or like 21 kilometers, which is really, really big. Um, so that. Like I said, it has two moons, but we'll see for how long. Phoebos and Deimos. Phoebos, however, is that question sort of a thing. So Phoebos has been moving closer and closer to Mars about every year about 2 centimeters, which overall not a lot. But when you think that this has potentially been going on since its creation, um, and it continuously gets closer and closer and closer. As we know with gravity, the larger the mass, the smaller the distance, they're going to want to come together and so Phoebos, they are predicting in about the next 50 million years, Mars will be down to only one moon, which could change again in the pure fact of how we got Phoebos was another moon collided, or another major object collided with Mars and created this dust ring, which then eventually became Phoebos. So Mars could have a ring and then a second moon again. So kind of weird. Mars has a very, very thin atmosphere to where that is where we are experiencing those extreme temperatures. The side that faces the sun is much, much warmer than the side that doesn't face the sun. So that is the second hurdle of getting man to Mars is how do we maintain those temperature differences? Mars does have strong winds and global dust storms. So that is another factor that needs to be considered as we are looking at traveling to Mars. There is evidence of water, or the fact that there was once water. And that lies within our polar ice caps of Mars, which we've already kind of talked about. And the fact that because of Mars's tilt, it does also experience seasons. Um, and you get some differentiation within those seasons depending on where it's at within its revolution. So, there's a lot to be studied and learned about with Mars, and that is why most space agencies are working toward getting there so that we can study this further and see what would we need to do for our astronauts in order to start the process of inhabiting a different object within our solar system and to go as far as inhabiting a new planet in the future. Because like I've said in class, we're throwing in the towel on this one. So yeah, so that is Mars, and more importantly, those are our inner planets. So that is the end of this first lecture. Please make sure that you have completed Mercury, Venus, Earth, and Mars's data points in that first table, and then answer the questions necessary on the notes page. And if you have any other questions, just let your educator know. That's why we're here. Take a moment. I'm going to record the outer planets here in a moment, and they should start right after this in my playlist. If you don't see it right away, just jump into my YouTube page and let's keep moving through our solar system. Fantastic. Thank you, 8th graders.